I'm very excited to moderate today's seminar featuring our guest speaker, Rediet Abebe. Now, before we begin today's session, I'd like to take a moment to acknowledge the land on which the University of Toronto operates. For thousands of years, Toronto has been the traditional land of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit. Today, this is the meeting place of many Indigenous peoples from across Turtle Island, and we are grateful to have the opportunity to live and work on this land. While some of us may be joining from different places today, we invite you to reflect on the history and relations of the land that you are on. Just a few logistics before we begin. This session is being recorded. Our speaker will present for about 45 minutes, followed by a Q&A. And during the Q&A, we usually encourage everybody to use the raise hand function in Zoom to ask your question. And then when it's your turn, we can call upon you and you can unmute and ask your question. But if you're in a place where you cannot unmute and ask the question yourself, then feel free to type it in chat and I'll reach out to you and make sure that you want me to read out the question on behalf of you. So without further ado, let me introduce our today's speaker, Rediet Abebe. Rediet is a junior fellow at the Harvard Society of Fellows and an Andrew Carnegie Fellow. Her research focuses on the intersection of algorithms and inequality with a goal of advancing the scientific foundations in this field. She has co-founded several organizations, including the ACM Conference on Equity and Access in Algorithms, Mechanisms, and Optimization. So that's a bit handful, but it has a very nice acronym called EMO. And the Associated International Research Initiative, and Black in AI. Rediet has received numerous accolades, such as the Hector Endowed Fellowship from the European Laboratory for Learning and Intelligent Systems, recognition as one of MIT Technology Review's 35 Innovators Under 35, the ACM SIG KDD Dissertation Award, and an honorable mention for the ACM SIG Ecom Dissertation Award. Rediet currently leads a large-scale evaluations of machine learning systems in commercial, legal, and policy contexts. And we are very excited to have you with us today, Rediet. And we are very much looking forward to your presentation on when does resource allocation require prediction. All right, so I'm going to pass off the floor to Rediet, but I just want to make one quick announcement to the audience that we had some initial issues with screen sharing before you all joined. So I'm going to give Rediet a chance to try it once more if that works out. But if it doesn't, then we have a backup option ready.
Yeah, it still does not seem to be working. So we're just going to have to do with the backup option and hopefully that's okay.
Sounds good.
Very good. All right, can I get started?
Yes, please do.
Okay, I'm assuming that's okay. Good, very good. Thank you so much for the kind invitation, Nisarg and everyone else too. I will say, you know, I knew of your work when I think I was in my first year of grad school, my first year of my PhD, when I was switching from math to computer science and was exploring. And so I've been following your work for some time. So it's kind of amazing to see how time passes and you know what all we've all been working on. So it's really a pleasure for me to be here. Unfortunately, you know, despite the many years that we've had Zoom as our, you know, part of our daily lives, we still are, I guess, struggling. Today I've been struggling with the screen sharing. So we have someone who's going to be screen sharing for us. So I'm just going to tell them to go to the next slide. So that's just going to be part of the presentation. I apologize. As Nisarg said, if you have any questions that are immediate, please jump in and ask. And if you can hold them until the end, then we're going to have a longer discussion at the end. So, you know, you can sort of like decide what would be most helpful for you as I go through the presentation. But I do hope that this is something that will be an engaged and interactive presentation because I think these issues are very timely. So, over the past several years, a lot of my work has focused on the use of machine learning systems in societal contexts, and in particular, how we have envisioned machine learning evaluation and what tools that have been built within that community that might translate into the use of machine learning in, you know, the policy context that I care about and that I would study, and what new tools may need to be built, right, to kind of acknowledge the unique challenges that arise when you're thinking about, let's say, resource allocation, which is a common issue that we have to solve. And in particular, you know, over the years, we're seeing a lot of predictive systems being used to allocate scarce societal resources. And the idea here is that, you know, if you're thinking of some Department of Education, which is what we'll talk about, or, a healthcare context, you often have very few resources, and you really don't want to waste them because you understand that they might be able to make a meaningful difference in outcomes that you'd care about, like, educational graduation rates, improving dropout rates, in healthcare context, maybe, health outcomes that you'd care about, like readmission to hospitals, and housing context, maybe minimizing homelessness, all these other things that we would care about, right? And so the idea here is you have scarce resources, you need to allocate them efficiently, and to do that, maybe we can use predictive systems as an intermediate step to identify the individuals that would be at greatest need of these resources. So if you go to the next slide, here, over time, what's happened is that there's this underlying assumption that we are really taking more and more for granted, which is that potentially prediction is helpful and maybe even necessary for efficient allocation, right? And I think this was something that was maybe more of a question at some point, but now it really seems to be an assumption that we believe so much that sometimes we don't even feel the need to necessarily acknowledge it. And so a lot of the work that I've done in the past few years has been really coming back to this assumption and asking when this is true and when it might not even be true, and when predictive systems may be actually actively not helpful. So if you go to the next slide, so this brings the question of evaluating predictive systems as a solution concept for allocation. So next slide. When you're thinking about this, basically there's sort of three overarching questions that you would ask. One is, first and foremost, I build some machine learning system that's predicting some outcome I care about, let's say, graduation rate, likelihood of graduating from high school. And so the first set of questions that you would ask are, is this predictive system accurate, right? Is it actually outputting probabilities that we think are, reasonable, that make sense, that seem to be sort of shared by the reality, right? I've sort of validated by the reality. And you might also care about issues of non-discrimination. So you might think about maybe it's accurate for some subgroups of people, but not for others, right? And so these are things that you'd want to avoid. And also other questions around the problem formulation, like, is the target variable that you have defined actually mapping to the real world problem that you think about, right? And so that's kind of one set of questions that's about the system itself. And then the next set of questions in the next slide that you have is, are they actually leading to the desired outcomes, right? So you might want to predict students at highest risk of dropping out, but these probabilities on their own are really only, as many people are saying, like, they're just really a means to an end, right? Ultimately, what you care about is to be able to use these probabilities to allocate resources so that you can actually improve graduation rates, which is a separate question from, is the prediction itself accurate? And so that's the kind of the second layer of questions that you would ask. And then the third layer of questions that you would ask is, these predictive systems exist in a broader system of decision making. There's individuals that are making decisions, policymakers that are making decisions, other predictive systems that you might be using in different contexts, right? So you have this broader ecosystem. And so when you're evaluating a specific tool, you have to think about it within this broader context of decision making. And so maybe the way that you would evaluate it and you would decide how valuable or not it might be could be affected by what other elements there might be within this broader ecosystem. So that's kind of, these are the sort of driving questions. And so today, if you go to the next slide, I want to talk to you about two papers. Really, we'll spend the bulk of our time on the first one, which is doing an empirical evaluation. And I actually think this might be the largest empirical evaluation of an early warning system within the US, at least, which we were able to do with the state of Wisconsin. This was a project that was led by Juanqui Perdomo, who is a postdoc at Harvard now and actually might be on the job market. And it was a multi-year effort, and I'm excited that I'll get to share some of our insights with you that made it into this paper, and a lot of other insights that didn't even make it into the paper. And then in the second part, which we'll do kind of briefly, we'll present a theoretical framework that shows that some of these insights that we walked away with from working with the state of Wisconsin are actually just things that you should expect to see more broadly. And so we were able to go through sort of a theoretical modeling exercise to show that these observations are not some weird quirk of the state of Wisconsin. It's a quirky state, but that seems to be not what was driving the insights that we have. And so it gives a little bit of a a sort of a theoretical backing to this empirical observation that set of empirical observations that I'll share with you. And in particular, for the rest of the talk, we're just going to focus on early warning systems. So what are early warning systems? If you go to the next slide, we, at a high level, they're a very complex set of systems, actually, but sort of by and large, what you should imagine is that you have a lot of data on students. It could be their demographic, like, their age, their gender, their race, disability status, and so on, but also their environment, like the neighborhood that they're in, various statistics about that neighborhood, like what's the median income, as well as the schools that they go to. Maybe you care about what fraction of that school is of this demographic, or what fraction of the school qualifies for free and reduced lunch, which is a sort of a very strong proxy for poverty levels within the US, right? And so you have a lot of information about students, the schools, the neighborhoods that they live in. And the idea basically is that you're taking this, building a predictive system, and the output is some sort of risk score that allows you to sort the students by risk. And for the rest of the presentation, we'll focus on dropout from high school, because that's, people's ability to graduate with a high school degree can really have a consequential effect on labor market outcomes and a whole bunch of other things as well. And so that's something that we may want to be able to understand well and be able to predict, so that we can intervene early to allow individuals to kind of move on with their lives with sort of the kinds of careers and lives that they would want to have, right? And so so this is just an example. Often you can also see these systems in, let's say, online context. Maybe what you want to predict is, if you have online courses, maybe you care about predicting which students are actually going to complete a course versus not. Maybe you care about predicting GPA. Maybe you care about predicting absenteeism, right? And so you can imagine any number of outcomes, educational outcomes that you could substitute instead of high school dropout risk. But by and large, the framework of early warning systems is kind of what's described here. And again, the desired outcome here is that you're able to sort of come up with a system of ranking students, so that you know which ones are at greatest risk of this undesirable outcome that you would like to avoid, or maybe the desirable outcome that you want to actualize. And you're using that to target resources and improve and improve sort of societal welfare. So if we go to the next slide, so this is sort of what we have. And what's been really interesting in the United States is that right now, over half of public schools, I think it's actually, this ratio is probably much, much, much higher. This is from a report from the US Department of Education 2016. But at the time in 2016, which was now almost 10 years ago, over half of US public schools were using some sort of early warning system, which is, a high fraction. And their idea was that, they're using these systems because predicting student dropout is what they would call a mysterious and difficult to predict problem, right? And so the idea is that, we have something like a dropout crisis. This was something that became actually like a very bipartisan issue that attracted policymakers' attention back in the early 2000s. There was a lot of policy conversations that happened and things that were instituted, many of which are controversial in some ways, but there seemed to be a consensus that, we have people dropping out at incredibly high rates, and we would like to kind of minimize that. And so early warning systems kind of emerged as one way to try to address that. So if you go to the next slide. So it was sort of with this backdrop that we've started this collaboration with the state of Wisconsin. This was back in 2021, I think, or maybe 2022. So this was many, many years ago. And this was a project that was led by Wanki Perdomo, whom you see on the top left, and my two colleagues here, Talani Burton at UC Berkeley, the Grad School of Education, and Moritz Hart at the MPI in Tübingen. And we struck up this collaboration with them. We really spent quite a bit of time, especially Wanki, we spent quite a bit of time just trying to understand what they've done, what tools they built, why they built it, really trying to understand the domain that we were working in. And we were fortunate to have this opportunity to get all the data that they had up until that point, which was over 10 years of data and all the models that they had built, and also actual outcomes, right? So we were actually able to get information about each individual student and whether or not they actually ended up graduating from high school or not, right? And so we struck up this collaboration where we were sort of tasked with helping them understand the extent to which their models actually worked or didn't work, and the extent to which it was allowing them to actualize the outcomes that they were hoping for. So if you go to the next slide, so to give you just a little bit of a background on Wisconsin dues, there's actually so much here. There's maybe we can discuss it in the Q&A, but just to tell you what you need to know for the results that I'll present, dues, which is the dropout early warning systems, predicts high school dropout risk for each student from 5th grade up until 8th grade. So each year they make a prediction, actually often twice a year, but at least once a year. They've been doing it since 2012. And for each student, they predict the likelihood of dropping out, which is a value from 0 to 1, but they also thresholded, and we'll talk a little bit about this. So they threshold these values so that each student really has just a risk category of high risk, medium risk, and low risk. And it's used by all the districts, all the public schools that they have, over 200,000 students every year. It has 40 plus features, which are the kinds of things that I mentioned to you, right? Demographics, academic performance, features that you would expect, community level information, and so on and so forth. They used models that are just kind of standard supervised learning methods for tabular data. And the output, as I mentioned, is this probability of dropping out, but also really what's so the most actionable thing for the schools was really just the risk category. So they weren't really necessarily looking at the probabilities, right? That schools were not distinguishing between like 0.78 and 0.79. They just really wanted to know whether it was high risk, medium risk, and low risk. And so these results were shared with the schools on a dashboard. There was a lot of things actually that were shared with the schools. And our understanding from spending time with them was that one of the main uses for what the Department of Public Instruction was sharing was the 8th grade model, which high schools used to sort of triage students as they were coming in, right? So you have a group of 8th graders who graduate, they get their, they get their grades and all this stuff, and a whole lot of data is collected. It gets passed to the high schools, but they also, have these risk categories of likelihood of dropping out of high school. And the high schools, because they don't necessarily know those students very well, they were really using this to sort of triage students and know which students to focus on more versus not. And so that's kind of the background that you would need for the results. So with this, if you go to the next slide, the first thing that we did was to just look at the risk categories and just see what, we have the actual outcome for the students. And so we wanted to see what fraction of students actually graduated from each of these risk labels. So you can see that for those labeled low risk in 8th grade, 97% of them ended up graduating. For those labeled high risk, 70% of them ended up graduating. And as a benchmark, the state baseline was 90%, right? So there's some sort of like meaningful, non-trivial classification of students by risk groups, but of course, this is only a part of the story. So if you go to the next slide, we looked at the actual probabilities, right? Because we also had access to that. And so what you have here is a calibration curve. So on the x-axis is the dues predicted probability. It goes from 0 to 1. And then on the y-axis is, if you were to bucket all students that have, let's say, about a 0.4 dues predicted probability, what fraction of them actually ended up graduating, right? And so that's kind of comparing the prediction with the actual outcomes that you have here. And so this kind of tells a slightly complicated story, because if you had sort of a perfectly calibrated curve, right, it would be on the x is equal to y line, which is the dotted blue line that you see here. But you see that that's absolutely not what's going on, right? So there's a sort of significant miscalibration that you notice, and in particular, dues is consistently understating the probability of on-time graduation. But if you remember earlier, what I mentioned was that the schools don't care so much about like the actual probabilities, right? And actually, schools have fairly similar dropout rates year after year. It doesn't tend to change that much. So they know what fraction of their population is at risk of dropping out, with some, margin of error. What they really care is if I give you 2 students, you want to know, is this student at higher risk of dropping out compared to this other student, right? So what they really care about is this sort of relative probability. And from that perspective, actually, dues is doing a good enough job because it has a positive slope. So by and large, it's not confusing. It's not swapping, the predicted probabilities of dropping out, right? So if I give you 2 students, the dues probability allows you to say this student is at higher risk than this student, and often enough that was true, right? So that was sort of like one of our insights, that you have sort of maybe not a good absolute risk of dropout, but a reasonable enough relative risk of dropout that was being computed by dues. So if you go to the next slide, the question that you'd ask here, of course, is now, well, this is just for the full population. What's happening if you look at different demographic groups? So if you go to the next slide, we looked at all the sort of different demographic groups that we had access to through their data. And I'm going to present just one of the results, but you know, what you observe here is going to map to the other cases as well when you look at advantaged versus disadvantaged groups. So here you have white versus non-white students. So white students is the calibration curve is the purple one corresponds to the white students and the orange one corresponds to non-white students. So this one was, you know, maybe one of the first interesting results that we observed, in the sense that what this says is actually induces a more accurate measure of absolute risk for non-white students, right? Because this orange line is closer to the blue dotted line than the purple line is. And so that was interesting, but if you think of this as, if you think of dues as a way to rank students, then actually you're maybe you have a little bit of a problem, because what you would have is that you're going to systematically overlook non-white students over white students. So just to see this as an example, let's say you were looking at a dues score of 0.6, right? So 0.6 corresponds to 80% graduation rate if you were looking at the orange curve, which is the non-white students, but it corresponds to about 90% graduation rate for white students, right? So a 0.6 means different things for a white student than for a non-white student. And in particular, the chances of graduating for a white student is higher than the chance of graduating for a non-white student. And so this was one of the first things that we shared with them, that if you were using this to rank students, which is kind of roughly what they were doing by and large, then you might be systematically overlooking non-white students. So not a very difficult thing to fix once you observe it, but you know, to my understanding, this was not something that they had noticed beforehand. So if you go to the next slide, so that's, you know, great that, you know, we were able to make some of these observations, some of which were, you know, better than we expected, and some things were maybe things that we hadn't expected, but we were able to share. But as I mentioned earlier, what we really care about is the dropout rates, right? Is if you're building this tool, presumably to allow you to allocate resources more efficiently, and presumably that means that you're going to actually improve graduation outcomes, then what you really should be looking at is the actual dropout rates. And so as I mentioned earlier, we were able to do this because we had the actual predicted probabilities, but what was emphasized for the schools was the risk label. So you have this high risk, medium risk, low risk categories. And this allowed us to do a natural randomization that was provided by this thresholding. So there was a threshold of, I think it was 0.785. And so if a student had, well, actually, maybe the thresholding is not so interesting, but basically you can imagine that there are these thresholds that exist between high risk and medium risk and low risk. And so if you look at that threshold between, let's say, high risk and medium risk, if a student is epsilon above, they would be labeled high risk, but if they were epsilon below that threshold, they'd be labeled medium risk, but their actual probabilities are very similar to each other, right? And so what we looked at was basically, if you took a small bowl around this threshold and you looked at actual outcomes, then if dues was, or the way that they were allocating resources, if that was aided, if that was improved by dues, then dues should have a sort of self-negating prophecy, right? Because if I have a 0.785 threat, like a probability of dropping out, if you tip me over by epsilon and I get labeled high risk, then presumably I'm getting a lot more attention, getting more resources, and that reduces my actual probability of dropping out. Whereas if I was epsilon below, then I'm labeled medium risk, maybe I'm not getting so much attention and resources, and as a result, my likelihood of dropping out has not been improved as a result, right? And so that was sort of what we were able to threshold. So if you go two slides next, yeah. One more. Yeah, very good. So actually, we can also skip this. So basically, we looked at essentially, this way of trying to estimate what the dues treatment effect is, and in particular, asking whether dues has a non-zero treatment effect. If you sort of make some very, very mild assumptions around smoothness of conditional expectations, if you go to the next slide, it allows you to estimate what the dues treatment effect is. And so what we found essentially is that between moderate risk and high risk, we think that dues may have a treatment effect of 4.8%. but between low risk and moderate risk, it was 2.6%, right? Now, this is a complicated story because, as you can see, the 95% confidence interval includes 0, right? And so we can't actually rule out the possibility that maybe DOOS has a 0, treatment effect, right? We can't actually rule that out. But the reality, at least in sort of education and similar enough domains, is that if you have a point estimate that's this high, like a 5% point estimate, and the confidence interval is like, missing 0 by this much, people would move forward and make a lot of interventions. That's just the kind of the reality of what's going on, right? So this is a sort of mixed it was a sort of mixed result. It wasn't like a clean result. But I think this was sort of enough from an education perspective that if they moved forward, I don't think it would have been an outlier. My suspicion is that this might have just been like if the program had run for like 5 more years, then I think maybe the confidence interval would not include 0. That's just my guess, but that was just with the data that we have, that was what we were able to observe. So if you go to the next slide, so this was sort of, for a while, this was actually the end of the story for us. We thought, okay, here is the set of models that they have over, 10 plus years. We think it's, not perfect, but it's accurate enough, at least as a relative measure of risk. And there's some evidence that maybe it's helping improve actual dropout rates. Maybe, that's kind of enough, right? And so maybe we can move forward. So there's a question here. I'm going to wait to address this question until the end because it's not immediate, but I appreciate you asking the question. Please keep chatting them if you have other questions as well. So for a while, kind of this was where we had stopped, and actually the project had even stalled for a bit because we sort of were not, something felt incomplete for us, and so we kind of kept chatting with them and trying to understand why something about the system hadn't quite clicked for us. And so we went back and we looked at exactly what was driving these the accuracy of these predictions. So if you go to the next slide, what we did was we divided up the features. So I'd mentioned to you there's these 40 features that they have. So we divided up the features into in what we called individual features and environmental features. And this is actually not as easy as it seems, right? Because things like race and gender and absenteeism, this is information about specific students, but of course it's affected by the environment and the environment affects it, right? But we were kind of more lenient, and anything that was like a measure of a specific individual, we just added as an individual feature. And so we were kind of more conservative in what we included in the environmental feature. It was only things like fraction of non-white students in a cohort, fraction of like students on free and reduced lunch, fraction of students with disabilities and so on, right? And so we divided up the features in this way, and then we trained like new models. If you go to the next slide, we trained new models to see how well an environmental only or an individual only predictor would do. And so if you look at this slide, this is for the environmental only feature compared to all features. And you see here that, and this is, models that we ourselves trained, and we see here that, with some exceptions, actually, the environmental only feature is pretty close to just using all the data that you have. So information about a student's environment seemed to capture so much of the signal that we were getting about their likelihood of dropping out. And this was, puzzling. And so we went back, talked to them some more. And if you go to the next slide, what we basically noticed is that Wisconsin, like many other states in the US, is very heterogeneous. Well, like some other states in the US, it's very heterogeneous, but the schools themselves are quite homogeneous. So this is what you see here is on the right-hand side, the standard deviation of the predictions across all the schools, right? So you see that it goes from 0 to 0.25 roughly, or maybe 0.3, but a lot of the schools are pretty close to 0, right? And so you see that there's a wide range of schools, some schools that have like kind of low standard deviation, some schools that have a higher standard deviation, but there's a wide range of schools. And then on the left-hand side, what you see here is the histogram of predictions for a specific school. We picked a random school. This is not so much an outlier. By and large, what you see for a lot of schools is that there's sort of like a specific point. In this case, it was like, close to 1, where you have like a lot of predictions are concentrated. And then like maybe there's one other place where there's like a few predictions that you would see. But by and large, it's, a lot of the the predictions that you get for individual students are concentrated for within a specific value for a given school. And in some way, this kind of this was sort of like it really changed our perspective on what was going on here, because what's happening is that, if you talk to a teacher, a public school teacher in a lot of states, including in Wisconsin, they would tell you that, schools don't tend to change that much year after year, right? It's, if you've been teaching for a really long time, or if you're a counselor, or, someone who's just in the system and have been doing it for a while, you kind of have a sense of roughly what the population is struggling with. And so if someone builds a tool, especially at the state level, and gives it to you, it matters less to you what it says about, a bunch of other schools. So what you really care about is, or at least kind of like from a triaging perspective, what you might care about is this giving me information that I don't already know, right? So is this giving me information beyond what I would have expected? So if I'm a high school teacher in a specific school, and I expect, about 80% of my students to graduate, maybe 20% of them might not graduate, I already kind of know that, right? So what I would want is for a predictive system to tell me with higher likelihood than I would, which 20% of the students might drop out, or what changes I might be expecting to see, right? And so from what perspective you're evaluating the accuracy of the system really matters. And so we did a lot of analysis. I won't get into sort of all the details of it, but essentially what we summarized this as is what you see on the next slide, which is that if you control for the environment of a student, the individual data that you'd get about individuals is like roughly sort of the outcome that you'd expect for a student is independent of their individual features once you control for the environment. This is, it's a broad summary of what we observed. It's not true everywhere, but at least around the threshold, which is what we were looking at, it seemed to be true to a very, very large extent. And we, studied this in a lot of different ways. And so if you're curious about the details, I recommend, kind of going to the paper to take a look. And this was really coming up even in sort of in ways that I was quite surprised by. So if you go to the next slide, what we found was that we spent a lot of time with the data, and we found that actually, wait, hold on, five schools out of the many, many schools that they have account for 10% of the high school dropout in Wisconsin, right? So we went back to the Department of Public Instruction and we were like, hey, did you know that actually these 5 schools is where most of your dropout is coming in some sense, right? And I think they knew that, obviously that dropout was concentrated in some schools. I don't think I'm not sure that they fully appreciated how much of the dropout was coming from these 5 schools, but it was the case, right? And so you do really have this heterogeneous state, homogeneous school phenomena that I was mentioning earlier. And so we then went back, and so if you go to the next slide, we then went back and we thought, just as a toy example, you could imagine, if I'm a Department of Education in some state and I already have statistics about schools from previous years and it seems to be stable, then I also have the option of going to my Excel spreadsheet, sorting the schools by their dropout rate, and just allocating my budget relative to the school's dropout rate, and telling the schools, this is what you're getting just based off of what the dropout rates have been in previous years. Your students, try to allocate it, do something a little bit better than just like randomly assigning it. I'm not even going to necessarily make huge assumptions about how effective the schools will be, right? Like that's one way to allocate resources. And so essentially where we got to was this idea that when we think about prediction in societal context, we think about these things like accuracy. Maybe we think about like what effect is it actually having, right? But it is also very important that you're not making absolute statements, but rather making a relative statement, comparing it to like a very basic thing that an education person could have done in the situation, which is just to use aggregate statistics about the schools to make decisions about how to allocate resources. And so we essentially designed, again, I won't mention too much of the details, but we essentially designed a simple mechanism that only uses environmental features, and found that would have been, in the state of Wisconsin, it would have been as effective as allocating interventions using these individual features. And, the details is in the paper, but this was something that was sort of like becoming increasingly more kind of compelling as we kept going in our study. And I want to convince you that this is not actually a Wisconsin issue, and maybe not even like some individual decisions that we made around how we analyze the model and so on and so forth. And so I want to go now to the next slide, to the next part of this presentation, which is to look at how we could study this theoretically, right? So let's step back again. As we mentioned, we care about how these systems work and whether they're actually helping us get to the desired outcomes, but we also care about how they fit within the broader decision-making ecosystem, and in particular, how they compare to sort of very simple metrics that a policymaker could use to allocate resources, right? That should be the benchmark against which we're comparing these tools, at least as a starting point. Maybe you might want to even try something more fine-grained. So in this next work, on the next slide, what we did was to study this theoretically, and I'll give you some of the details of the model and some of the key results. This was a project that was led by Ali Sharali, who's a PhD student of mine and Moritz Hartz at UC Berkeley, doing a fantastic job. He's going to be on the postdoc market maybe next year. And so we had this sort of theoretical endeavor where we looked at, if you go to the next slide, we looked at sort of what we called these individual prediction-based allocation mechanisms, right? So basically we're saying you have a set of individuals, in this case, it's students, they have their likelihood of dropping out, right? They have their risk scores, and you have a budget of, let's say, you can only allocate resources to 4 students, and you want to know which 4 students to target, right? And so you build a predictive system that outputs individual risk scores, and you use those risk scores to rank the students, and then you allocate the intervention or allocate the resources based off of these risk scores, right? So these are the what we called ILA, individual level allocation or individual prediction-based allocation mechanisms. And we compared these to, if you go to the next slide, what we would call unit-based allocation mechanisms, or ULA. So here it's a school-based allocation mechanism. And the idea here is that you know what schools students go to, you know what the sort of aggregate statistic of welfare for that school is. It could be, let's say, last year's graduation rate. And what you then do is you take that information about the school, about that unit. It could also be neighborhoods, it could be hospitals, you can kind of think of your favorite example here, and you allocate the budget relative to the sort of the aggregate welfare of these schools. And then within a given school, so here the left-hand side is getting 3 of the 4 budget that you have, and the right-hand side is getting just 1, right? And then you say that the given unit is going to allocate that a little bit better than random. It's not going to be fully random, but a little bit better than random, right? So that's what we're going to call sort of a unit-based allocation mechanism. And there's a lot of reasons why you might care about this way of allocating. It's cheaper, right? It's easier to implement. It's less contested by and large, but it also has, clear downsides, right? And in particular that unless you're making very strong assumptions about these units and what they know, it could be the case that they're not going to do a good job. And so you're essentially wasting resources, and we don't want that, right? And so there's some sort of trade-off that you're trying to navigate here. So it would really help to know, next slide, it would really help to know when an individual level allocation, or ILA, is better than a unit level allocation, so that it's worth putting in the time and effort to build a good individual predictive system and use that to allocate resources. And so what we found here, and this is a sort of spoiler alert, is that if you go to the next slide, what we found here is essentially that if you look at the inequality, the between unit inequality. So here you could be thinking about, let's say, graduation rates across schools, and then you could look at the inequality of those like aggregate statistics. Essentially, what we find here is that if that between unit inequality is moderate or high, then unit-based allocation really does like as good a job as you would be able to do. Alternatively, if the budget is low, like you don't have a lot of resources that you're giving out, even if the inequality is low, you could really have the unit level allocation being desirable. So here green corresponds to ULA, or the unit level allocation, doing as good a job to compare to the individual level allocation. I see that I missed a bunch of questions actually. So let me just read these real quick.
These are all kind of more open-ended discussion questions, so we can handle them at the end.
Okay, I'm also almost done, and I think we can have a long discussion. Okay, thank you, Marzia, for the questions. I will start with those when in like 4 slides. We're almost done. So essentially, yeah. So basically, this was what we sort of were able to observe, and so we did. I encourage you to take a look at the paper. I didn't actually include a lot of the technical details here because I wanted to have like a broader discussion about what's going on here. But essentially, we did a lot of analysis to show that if you have any of these things being true, that you have not that much budget or you have moderate to high inequality, then ILA is not, there's no reason really, at least from this kind of simple modeling assumptions that we made, there's not really a reason to switch over from the unit level allocation. And so this gets us to the second to last slide, actually. And so if you step back, essentially what we've been looking at so far in this presentation, but really also in a lot of other papers that have been coming out from colleagues, a lot of things that I've been working on, a lot of things that actually both Wanki and Ali have been working on separately, which are really, really fascinating in my opinion. What we're seeing is that, there's obviously an incredible amount of work that's happened by the machine learning evaluation community that allows us to have some level of confidence sometimes in how well these tools are working, right? But when you're taking those tools and you're deploying it in a societal context, especially in a sort of a constrained problem like resource allocation, then there's a whole bunch of other things that you now have to take into consideration, right? Like, for example, today we talked about, what's a benchmark against which you're comparing the efficacy of your tool. But you could also think about like, maybe you don't really need a lot of information about students. Maybe all you need is like, very, very, very basic statistics. So we talked to the city of Chicago, and they told us they don't actually have any complicated models. What they have is a system that they've been using for the past 20 years that they were like, it's worked well 20 years ago. It keeps working well now, essentially. And all it does is it keeps track of, I think, absenteeism, how many classes a student failed, and then one more thing I'm forgetting, but it was something that's like that basic, right? And that's it. That's all they use, and they have like a very basic system that they've been using, and it just seems to be doing as good a job as, as any of the other more complicated models that we've seen from other states. And so you can think about, what is the benchmark against which you're comparing the efficacy of your system. You could also think about, when we use these systems, we often look at sort of one problem at a time. We look at like, okay, education, we want to reduce dropout rates, housing, we want to increase, housing stability, healthcare, we want to make sure that people are getting early screening, right? There are all these like pieces that you look at. And one policymaker that I talked to said, it's like trying to solve a Rubik's Cube, but you can only see one face at a time, and you're not allowed to see the whole Rubik's Cube, and that is just a very difficult problem, right? So you can think about what is happening here holistically, and how does the confidence that we might have about these systems in this kind of much more siloed, isolated analysis, how does that actually map to a much broader ecosystem level analysis that you may want to do? So if you go to the next slide, I have a few kind of ongoing things that I'm interested in, that I've been working on. There was one thing that I actually wanted to present today, but there was not going to be enough time. But we looked at essentially the effect of timing, and in particular, this is with Ariel Prakasha here and Ali. We looked at how, to improve your prediction, often you have to collect data, and that requires you to just wait. But as you're waiting, actually, maybe the bad outcomes that you're trying to avoid are happening, especially for those that are already at high risk. And so we thought about this kind of trade-off that happens between time, waiting to improve accuracy, but also waiting, and as a result, actually, like the bad outcomes that you don't want being realized as a result of this waiting, right? So there's a lot of kind of interesting angles, I think, to just kind of go off and study and analyze empirically, but also theoretically. And I would be happy to chat about any of these, but I also see that there's some interesting questions, and I'm guessing some other questions that folks may not have shared. So I'll stop here, and Nisarg, I can start reading these questions, or how would you like to proceed?
Yeah, I mean,
and thank you all for your time.
First, thank you so much, Rediet, for the wonderful presentation. I think you have given us a lot to think about, and I think that it might even take the audience a bit of time to like digest all of that and questions. But we are happy to begin our discussion period now, and we welcome questions from all of you. And just as a reminder, if you want to ask a question, our preferred method is that you raise your hand in using the Zoom control options, and then we would when it's your turn, we would welcome you to turn on your camera and ask your question yourself. But if you're in a space where you are not able to unmute and ask the question yourself, then feel free to also type it on chat and indicate whether you want me to read out the question on behalf of you, and then I would be happy to do so. All right, so Oh, I see that there's already a hand raised. Some people maybe have faster digestion systems. So, Kelly, would you like to unmute and ask the question?
Thank you very much. And thank you so much, Rediet. It was a great talk. So I'm a PhD student here at University of Toronto. I work with Shayon Gua. And we've sort of been working on a project that's similar in nature in that we're looking at early warning systems in the Ontario college system. So, and we found in our initial studies very similar results that really sort of program level, looking at one college, program level information is much more predictive than individual student information. But one thing that's a little bit different is the interventions. And I'm curious to know your sort of comment on, I'm assuming that the different schools within the Wisconsin system have different interventions available or apply interventions differently or interventions of different quality. And I'm wondering how the differences between those interventions and their effect on dropout rates, how you think that would impact the reliability of the DEWS algorithm.
Yeah, excellent question. So yes, this is a question that also keeps me up at night. Yeah, no, this is an excellent question. So in the study that we did, the studies that I presented, we really wanted to strip away questions around intervention. We just said, let's assume that you have an intervention, it works well, you even know how well it's going to work, right? Let's just even concede that. Let's just concede all these things. Like, let's just assume causal inference is easy and coming up with interventions is easy, and we know exactly what they're going to do, right? Even then, this still holds. What I'm saying still holds. Like, even in that situation, it still says that if you have segregated schools, it's enough for you to just use information about the schools to just to allocate the resources, right? So even then, that's true. But there's an interesting question that you're raising here, which is that when we talk about the efficacy of these predictive systems, it really should be relative to a specific intervention, right? Otherwise, what exactly are you doing here? And in the case of Wisconsin, it was a complicated situation because they really didn't want to be prescriptive to the schools and say, here is what we're going to give you. Here's how you should rank the students. Here's exactly what you would do. That wasn't going to work. Wisconsin is a very diverse state. What makes sense for one school is not going to make sense to another school, right? And so they really didn't want to be prescriptive. They had sort of vague guardrails around, like, we trust that you already have your own way of deciding who's at high risk, but maybe there will be some students that we flag that you didn't catch. And so maybe those students are especially ones that you should kind of start with. And, and I think there was a lot of efforts also around just trying to educate the schools about what interventions might be more appropriate and more helpful, and also trying to kind of connect the schools and so on and so forth, right? So it was a much broader effort. I do think that there's a lot of questions that still remain. One being that, and actually there's recent work by Brian Wilder, who is Nisarg's academic sibling. I don't know where, I don't know what the academic family is. Okay, there's somehow there's some relationship here. Okay, Brian Wilder has done some really interesting work. I think other folks as well, where they're looking at the if I have a fixed treatment, like if I have a fixed intervention, right? Let's say I'm looking at the effect of like tutor hours, then the responsiveness of students to that intervention is not the same thing as their risk of dropping out. It could be the case that students that are really, really struggling are going to benefit most from that. It could be the case that the students who are not struggling know exactly how to use that time, and so they might benefit most from it. It could be the case that the students who are really struggling there's just other stuff that's going on for which tutor hours are not going to help, that students who are not struggling have their own extremely refined way of doing things. And so that's just not going to help. And maybe the students in the middle are going to help, right? And so when we use these predictive systems for allocation, there's an implicit assumption that we make that the way that you rank the students by their risk is the way that you should rank the students by sort of like relative how much they would benefit from a specific intervention. And that gets messier if you have a lot of interventions that are going on.
Yeah. Okay.
So,
yeah, thank you. Yeah. And
so it gets, yeah.
We found very much the same thing. I mean, the college we're working with even found that, even if we can identify the students that need interventions really well, the students don't opt into the interventions because, of course, you're dealing with a group of disengaged students at the college level, and disengaged students don't really sign up for workshops. So, okay. Thank you so much. I might follow up with an email if that's okay.
Okay. Yeah, please go ahead. My email is on the slide, but I'll chat it again. Yeah.
Thank you.
Yeah, of course.
That's
Thank you,
amazing.
Callie.
We do have questions on chat, but I prefer to take live questions first. And Gordon and Marzi have both asked me to read out the questions on their behalf.
Okay.
So let me go to Vera first, and then I'll come back to Gordon and Marzi's questions.
Thank you for letting me jump the queue. That's not very fair, but I appreciate it. I was wondering, hi, I'm Vera Habanska. I'm an assistant professor here. I was wondering, I don't know if this is too off base, but I'm wondering how much you know about the procurement of the dues algorithm. Was it insourced by the department, the DPI, or was it something that they kind of got grants and like outsourced? So I'm like, who stands to lose if we say that we don't need these things? And how, what do you know about
question.
that?
More than I want is what I know more than I want. So this is an excellent question. We spent quite a bit of time on this, actually. It's all bad news, but I'll share it anyway. So actually, I don't remember a lot of the details of Wisconsin. It was, supported by the government, right? And there was just a lot of transparency. I don't think there was anything that we found there that I thought was suspicious. This was also like many years ago. After our study came out, and then there was an article by the Markup, which is like a sort of, the Markup was started by people who used to be at ProPublica, so it's a sort of a ProPublica-like outlet. So they had done a different kind of study using the same data and same models, but a different kind of study that you can look up called. I'm blanking out on the name. I'll just chat it right at the end of my response here. But anyway, so this article came out, our paper came out, maybe some other conversations were happening, and dues actually decided to just shut down the program. So they no longer have, as of like last fall, I think they don't have it anymore. And what's interesting is we had many conversations with them, and they asked us, what should we do, right? And I was very hesitant to say, you should have it or you shouldn't have it, because the upside of first of all, they've had it for a while. The schools use the system for all sorts of reasons. They have a lot of data that's available on the students that I think is really valuable to the teachers, right? It gives you a lot of information, especially when you're going from middle school to high school. All the teachers may not necessarily know you. And so there was a lot of data that was actually helpful to them. And the other thing that was a real danger was that, at least Wisconsin gave us access to the model and the data, and we were free to just publish whatever we found, right? There was no restrictions around that. But the reality of the situation is that if they didn't have dues anymore, because schools are still used to having some such system, they might lean more on for-profit companies. So PowerSchool is one that was flagged, that the families already use to see homework and grades and whatnot anyway. These companies are for-profit. They're not going to give you access to their models. Why would they? I didn't even know about it. It's just something that's out there. And if you're in the school system, you would know, but if you're not, you wouldn't know. And as far as I can tell, these companies are building early warning systems as part of like the data they've already collected. And so what they flagged was that maybe the schools are going to start using whatever these companies built, and that might be a much more dangerous situation than what we're in now, because at least with dues, the data that they use is kind of like state, it's transparent, and it's these 40 features are not random features. This was like a big discussion that was happening across the country in the early 2000s. But with something like PowerSchool, they could use data around how often you log in, where you click. There's any number of things that could go into it. And so, who knows what's going on in there. So that's one thing. And then the second thing that I want to share, and this is other bad news, I guess, is that we were really curious about how much these tools cost to build and to maintain. And so we spent quite a bit of time trying to identify each state, but then the system for each state, and try to get information. And that is not an easy task. It's not a very transparent thing. It's not the worst thing that's going on right now, but I do think it's important that if you're building some sort of system that's being used to triage students and what resources they get, that information should be as transparent as possible. So, yeah.
Perfect. In the interest of retaining a little bit of fairness, let me go back
Yeah.
to Gordon's question. So
Yeah.
Gordon has asked me to read out the question on his behalf, and he asks if you expect this type of ML capabilities, or in your case also the particular methodology of eval of ML based interventions that you have developed. Do you expect that to have a high degree of reusability? Can you use that same methodology to evaluate kind of more larger scale systems such as country level economic policy decision making and whatnot, or do you think that some sort of more maturity would be required for scaling up to that level?
That's a good question. I don't know. I really don't know. I think that it's not. I think this question of, so what we found in this work and in the work with Arya Prakasha that I've mentioned, and what I'm sensing from just reading between the lines, maybe of other projects that I think are exciting that I'm not involved in, is that this question of like inequality as the explaining mechanism, it seems to really keep coming up over and over again. It seems like if you have a policy problem where you don't have a whole lot of inequality, then these predictive systems or like kind of individual targeting could be much more effective. But if you have a situation where you have a whole lot of inequality, that a lot of the signal that you'd get from an individual predictive system is contained in some sort of aggregate statistic, whether that's about the unit that they're in, whether that's early signals that you see, whatever it might be. So that seems to be like a consistent theme that I'm seeing. And so I would say that if something like that is true across many domains and policy settings, that's a pretty big space, actually, right? So, and I suspect that something like this might be true in a lot of domains. It doesn't say anything about what do you do if you don't have a whole lot of inequality. Maybe the answer is like, it's fine to use these types of predictive systems. Those problems don't keep me up at night, but the problems where you have a whole lot of inequality do keep me up at night. How does it translate to questions like, NASA space programs? I don't know. I think that's, manufacturing. I don't know. I think that's probably something that would require different machinery and different problems than ones that we see in education and housing and other such domains. Yeah.
All right. Let me move on to Marzia's question, who has also asked me to read out the questions on her behalf. And I think both her questions are somewhat related. So she asks if there is an argument to be made for doing this type of environment-only model, and whether that's a better idea for human-facing algorithmic decision-making settings, because they can be intervened on. And also, I guess, like somewhat related is her second question on whether you would advise this kind of individual versus unit-based analysis to be done more broadly, and because there are some examples that she nicely pointed to where individual based policies have resulted in poor outcomes for students.
Absolutely. Yes, absolutely. So, thanks so much, Marzia, for the question. I do think that this kind of environmental only modeling is important to do, if for nothing else, but to just know, what have you contributed here that, people didn't already know on the ground, right? Because when we evaluate these systems, we think of it in like this very top-down way, but when they're being used, it's very bottom-up. Like it's an individual doctor or an individual teacher or an individual counselor that's using it, right? And so if you're going to say, I built this thing and I'm super proud of it and it does a great job, it should be relative to like what they would have already known. And so I think that's an important, I think it's an important thing to do. There might be other things as well. And what Marzia's question implies, or what I'm taking from it, is also that there's some interventions that are happening at the environment, right? So you could think about allocating tutor hours, or you could think about hiring a math teacher for the whole school, right? And so if you hire a math teacher for the whole school, everyone in that school is going to benefit from it. And so I think doing this kind of environmental only analysis also allows us to think about like what problems can be solved at the individual student level, or what problems can be solved at the environmental level. So when you're thinking about improving dropout, you're thinking, I have this budget, I could, assign some number of students, some number of tutor hours, or I could hire X number of math teachers and, assign them to specific schools, right? So really the trade-off is happening across many dimensions. And so I think if you're finding that a lot of signals contained in the environment, it might also suggest that the interventions could also really be more geared towards environmental types of interventions. And so I think absolutely. I think it is the case that this kind of unit level analysis is in a country that's as segregated and in domains that are as where the segregation appears as blatantly as in education and housing in the US, I do think that this probably shows up a lot more than we think. I think there's many reasons why that happens. I think some of it is also that the unit at which we think about the unit at which we formulate a problem is also the unit at which we think responsibility exists, right? So if we have high dropout rates and we're thinking about individual likelihood of dropping out, then I think on some level, it also allows us to talk about the issue of dropout as being like, let's find the students who are dropping out and try to like do something there to, to reduce it. And that can also, of course, get weaponized in a different way as well, right? You could say some students are just not trying hard enough, their families are not trying hard enough. And so I do think that there's like political and on some level philosophical reasons why we feel more comfortable thinking about the unit of an individual and not necessarily the unit of like a neighborhood or a state or or a country, right? Because that's also the unit which you'd have to take responsibility. So yeah, I think this Nevada example is I think it's pretty telling. My guess is, Marzia, in the work that you all do in healthcare, you might end up finding a lot of things like this also appearing at at hospitals. Some hospitals are much better funded and have a whole lot of qualified people and plenty of them and all that, and then other hospitals are just scraping by, right? And so outcomes are also going to be driven by that. So yeah, absolutely.
Yeah, actually, that also kind of is somewhat related to Gordon's question, right? I mean, I think healthcare is a great example. While I mean, it may not be clear like how this would extend to something like NASA space programs, but like the healthcare setting has a direct mapping to what you are doing, and yeah, the inequality between the hospitals and everything.
Yeah.
So,
yeah.
All right, let me go on to Laura's question, who has been patiently waiting.
No problem. I think you mostly answered my question that I put in the chat, but I do kind of maybe have a question for you about the disconnect between like the imagined outcomes of these tools. And I really like the way you operationalized it, like very specifically, like, are we going to actually like increase graduation rates? But to do so, you have to allocate resources like time and money, and which probably won't save money. Right. And so I'm coming from like the health sector where like the aim is to introduce these tools to make the health system more efficient, which means save money, time, resources. And yet so many of these tools actually require the opposite, like a more focused attention on a specific problem.
Yeah.
And so I guess it just comes to this kind of conundrum where I see these tools sort of being developed where they're imagined they'll do these things, but then the reality is that they won't, because you actually need money to invest in them to make them work. So I guess if one, I guess, are these tools is there an opportunity to like sort of advocate for increased resources for specific communities or groups with this kind of unit level approach? Or how do you imagine sort of like being able to use these tools to reallocate resources, which might mean increasing budgets or finding additional sources of funding? Like, I don't know if that makes sense. I guess I'm just.
Totally makes sense. Yeah, it totally makes sense. Actually, I do want to go to your question as well, because I did mention it briefly, but I want to mention one study that I think maybe would help you in getting there's a lot more going on here. So one of the most popular studies in economics is this study called the Moving to Opportunity study. It's actually like they did this big study, but there's like a lot of papers associated with it. It happened a really long time ago, maybe I want to say 15 years ago, but I could be wrong on this. Maybe it was more like 10 years ago. And what they did, I'm going to get the details of this like a little bit wrong, or maybe very wrong, but this is roughly what they did. They essentially randomly assigned families, I think, housing vouchers or something that would allow them to be able to move into neighborhoods that they would not otherwise be able to move to. And then they tracked, this might have even been longer ago. So they tracked, so some people were able to move to kind of richer neighborhoods than ones that they could afford, and some people were just not. And they tracked what happened immediately after, a year out, and then a long time after they were able to move. And I think broad strokes, again, the details might be a little bit different than what I'm saying here, but broad strokes, I think what they found was that in the short run, there wasn't like as much of an effect as you would like, but in the long run, it actually had a huge effect in terms of, especially families. I think this was with families with kids. The schools that these kids were able to go to improved, all sorts of things that you'd care about, their ability to sort of like the educational attainment metrics that you would care about, the jobs that they would get afterwards, and so on and so forth, right? And so this is one of the bigger studies that exist that I think kind of looks at like essentially even individual interventions can really be changing your unit. It's sort of saying like this environment is, maybe has more resources, so I'm just gonna let you move to this environment and kind of have like a desegregating effect in that way. And then there's this kind of complementary study that exists by Elora Daroncourt, who's at Princeton. She's also an economist and just one of my favorite researchers, where the paper is called "Can You Move to Opportunity?" And she essentially looked at how the environment sometimes responds to the individual. So she looked at what happened during the Great Migration in the US when a lot of African Americans were migrating from the South to the North for like opportunities and, just like greater freedom, right? And what she found, and she establishes this in a lot of different ways, but what she found was essentially that as people were like moving up north, though the cities that they were moving to changed in response, right? And she looked at this by measuring how much they invested in police and so on and so forth, right? And so there's this kind of interesting thing that happens where like, we think of units as also like, they're sometimes very well defined, right? Like here's a building of Baldwin High School or something, right? But actually, that high school is going to like shift depending on who's inside of it, right? And so I think that's a kind of an interesting thing to track this and understand, the complexity of environments and what social scientists have to say about it. I think it's just a really it's quite telling, is what I'll say. I think in terms of your question, I feel like how do I say this? I don't know how you can advocate for positive change. I really don't. But I do know how you can advocate for like minimizing misconceptions. And I think it's not a coincidence that as we build tools that shift responsibility to individuals, that is also correlated with having fewer resources, right? Like, I don't think it's a coincidence that as people build early warning systems, you're also funding schools less and less. I think these are like kind of related things. And the idea here is something along the lines of, we have enough resources, we're just wasting them because we're not actually identifying the right students. And if we had a system that allows us to do that, and it was this magical machine learning system that just like tells you exactly what you need to know about each individual, then we don't need to invest as much, right? And so I think that the way I see this work that we're doing is to use these technical tools, right? These are the same types of tools that are being used to justify why these tools are being built, but to use these same tools to evaluate when that does or does not make sense, or at least when that doesn't make sense. And I think, at least in this case, we can say if you have a lot of segregation across the schools, your problem is not identifying individual students. The teachers can do a good enough job. Your problem is that some schools are, 10% of your dropout is coming from 5 schools out of a state of 500 schools. You could just take the money and just give it to those 5 schools.
All right. I have a couple of questions I've been dying to ask, but I was trying to be polite
Yeah.
as the host. So first, I think kind of so let me make sure that I understand this correctly. In the theoretical model that you had, it's impossible for the unit-based system to actually outperform the at least on a statistical level than the individual-based system. It's just that it can perform as well, and then it basically says, why are you doing something so much more complex when there's something so much more simpler that can actually do just as well? But is that right? In the
That's
theory?
right. Right.
But
Yeah.
then I was kind
yeah,
of wondering that
yeah.
there could be realistic kind of concerns in practice, which can actually make the unit-based system outperform the individual-based system. So have you thought of like dimensions? I'm thinking of like there being like, say, bias in the data, which can make the individual-based system actually worse. And when you kind of do things on aggregate at the unit level, then maybe that bias cancels out and kind of more. Yeah. So I don't know if you have thought of dimensions that can actually make it better rather than just not.
Yeah. Yeah, so I'm just chatting the papers actually in case you're curious to see the details. So with the theory analysis, which I didn't get into, we make this assumption that basically the predictor is we assume that you pay a very small cost to make the predictor as accurate as you want it to be, right? And so you pay some, and that's basically that ends up being very important for the theoretical analysis. And we made that decision, even though it actually makes our lives like it makes it harder for us to be able to make the points that we did. We made that decision because I think that I think that issues of like bias and issues of just like your predictor not being accurate are serious problems too. But I think that there are problems that remain even if you had a perfect predictor, even if it wasn't biased. You still have this question of like, well, you still have to build this thing. It's going to cost you some amount of money. And does it actually buy you? Like if I tell you I have a predictor that's 100% accurate, how much are you willing to pay for it? You might be willing to pay a lot. But if I have two schools, one of which has a 100% dropout rate, one of which has a 0% dropout rate, you should pay nothing for that because you already know who's going to drop out just based off of what school they go to, right? And so the question is, are schools in Wisconsin or in other parts of the US closer to this kind of extreme example that I mentioned? And it seems like actually from like at least a sort of a statistical perspective, they are actually closer to this sort of more extreme example. I think what you're mentioning around bias definitely exists. It definitely is there. Like I think the calibration plots that I showed is one example, right? You are not making the same decision depending on whether your student has a disability or not, or they're white or they're not white, right? And so I think that is there, and it would make the problem even worse. I think there's also questions of like, we think of predictions as like not costly. Like we acknowledge that maybe it takes time to like collect data and build a model, but there's also the cost of like labeling someone high risk, right? I think it could be positive. Maybe for some students it actually is positive because they get more attention. But this markup article that I mentioned earlier, it's called False Alarms. It came back to me, the markup. So I'm just gonna chat that while I'm speaking. What they argue a lot of different things, but one of the things that they argue is that from all the interviews that they did, they find that because Black students were labeled high risk at a higher rate than white students, which you can also see from like the calibration curves that I showed, there's also this additional psychological impact that has, right? If you're a Black student, you're already kind of feeling like an outsider and othered, and then someone is like, you're at high risk of dropping out, right? That does not, maybe that helps in some ways, but it also hurts in other ways, right? And so if you're thinking about what's the cost of prediction here? What's the cost of labeling someone high risk? I think that could be interesting. And actually, this shows up in healthcare too. Right? Because a lot of the early diagnostics that we do are a sort of prediction, right? We're not like 100% sure in all cases, but it's kind of a sort of prediction. But if you end up having a false positive, for example, then you're going to run more tests. There's the stress and time and cost to the individual, right? And so you can also think about that, right? And so I do think that what is like the cost of prediction beyond just how much money do you have to pay to like build it is an important dimension. And then I think coming back to your question, what I mentioned earlier around like maybe the intervention that's most effective is an environmental intervention, but you're not going to get to that through individual predictions, right? That it's just the moment that you're thinking about it this way, you've formulated the problem in that way, and you're not going to think about environment, And so I think there's also that. So there's so many different dimensions to explore here. Yeah.
That's very insightful. One more question. So I was very fascinated by this kind of self-canceling effect that you mentioned where, if somebody gets kind of labeled high risk and therefore they receive a lot of intervention and resources, and now actually they become low risk after that, right? And I recently worked on grading mechanisms, and I was kind of thinking of the exact opposite effect where somebody who scores an 89 gets an A minus, and somebody who scores a 91 gets an A plus. And because of getting that A plus, they actually kind of get a psychological boost, and they get more motivated in the next exam, and they prepare harder. And so actually there it's not self-canceling, but it's rather diverging, right? And so I hadn't thought of this effect kind of in a more broader context, but I don't know if you have had any thoughts on more kind of other types of interventions where you don't have a self-canceling effect, but rather a kind of a self-boosting effect.
Yeah. No, so so I think
prophecy, I guess, in some sense.
Yeah, no, I think you can have that. I think the grading one is a good example. It's funny that you mentioned that. So Eva Tardosh, who's a professor at Cornell, where I did my grad school, she tells the story of, in the sort of intro to computer science class, they, it's a tough class. You have the full range of scores that, grades that students get. And she says that the students who get a B- are very interesting, because if they're a man, they go off and do computer science. If they're a woman, they're like, I guess I suck at computer science, and then they leave, right? So even like the same sort of like label could have very different effects depending on whatever it is that you're coming into, right? Whatever social pressures there are and expectations there are, and things you may have internalized and things that's communicated to you, right? And so I think, how do you deal with that, right? Like when a B- says such different things depending on your background, it's complicated. So so I think, this high risk label could also be a positive thing. It could just be sort of motivating for some people, and for other people it could be just like one more thing communicating that you don't belong, and it's not going to work out for you. Yeah.
All right, that's amazing. All right, so I am guessing that there are no more questions. So in that case, let me thank you once again, Rediet, for the excellent
Thanks so much.
presentation. I think all of the audience members, I think, got a lot to learn and a lot to digest from this presentation. And this concludes our seminar. And I also want to thank, by the way, all the audience members for being here and asking all these insightful questions. So this concludes today's seminar, and please join us again next week on Wednesday, November the 13th, as we welcome Aziz Haq on the Frank and Bernice J. Greenberg Professor at the University of Chicago Law School for a talk titled The Geopolitics of Digital Regulation. So we look forward to seeing you then.